Welcome back to the shop, everybody. It has been probably a good 8 weeks since my last video on the waste oil burning water heater version 1, and in a lot of those videos I have been promising a new and improved version of the waste oil burning water heater, and this video is the kickoff for that build. So looking forward to getting this this project underway. It's been quite a while, and I'm looking forward to seeing how well this is going to work for us. So in our version 1.0, we had a waste oil burning chamber here. This was built out of a 20-pound propane tank, and on top of that we cut the bottom half of a 30-pound propane tank off and welded it to the top of that combustion chamber. And through the center of that storage tank is our flue, and that is how we exhaust all of our combustion gases. So this would be considered more of a storage water heater. It's not necessarily for rapid heating. It does quite well. It puts out a considerable amount of heat. I think in one of the videos there, I was able to estimate somewhere around 27,000 BTUs, and so the way I was able to determine that was basically looking at the start and end temperature, the volume of this tank, and using those parameters I was able to come up with an estimate of how much heat transfer we were seeing from the combustion of the waste oil going into the water as heat. So like I said, it worked quite well, but I think there is room for improvement, and that's why we are here today. So this is our build plan for version 2.0. We're going to start by preparing this 30-pound propane tank. The valve is still on. It's still got paint on it, so what we're going to have to do today is, of course, remove the valve, purge any of the propane left in the tank. And then once that's done, we can start to prep the tank for fabrication. So the overall kind of main differences between version 1.0 and 2.0 is, as I'd mentioned previously, the first version is more of a storage tank. It does quite well in that matter. The second version is going to be more of a boiler, and there will be no storage of water in this particular version. And so to achieve that, we're going to actually use a little bit of a different technique here. So as you can see, I have this coil. This is a stainless steel wort chiller. This is used for home brewing beer or other types of alcoholic beverages, but for our purposes, it's going to do quite well. So the idea here is to basically, once the tank is prepped, cut it in half so that we can actually route, or I guess I'd say install this coil inside of this top half of the tank, and then use the flame to heat this coil directly, and then that will be circulated, of course, using a circulation pump to get water flowing through this unit and out to where we need to use it. So there's a couple more finite details that we'll go into throughout the build, so I will get into a little bit more of the design detail for that as we get to those topics. So be sure to subscribe, and you'll be able to see all of the little details that are going into this build. But for now, we need to get started. So we're outside here, and I find the best way to remove that valve, it is installed very tight, is to secure it to a post or something that is going to hold that tank really well for us, and then with a wrench and a bar for some leverage, we should be able to break that loose. So as we're filling it, we are displacing any of the remaining gases in there. So you do get a strong odor of the propane odorant, and basically it's just a good indication that yes, there is still gas present. But once we've filled this vessel completely to the top with water, we will know that there is no gas left. And now the odorant does leave a bit of a residue, and even once we've purged it, you will be able to smell that, but you can rest assured that by doing the water purge, you have removed any of the gases, so there is no risk of any kind of explosion or fire at that point. No gas in there whatsoever, so we know that the tank has been purged and it is completely safe now to work on. So a quick side tangent here. In the previous videos, I was trying to measure what the heat output of the version 1 waste oil burning water heater was, and so I was trying to estimate the volume of this tank with the bottom removed, and so I came up with, it's a little late, but a great way to try and determine that. So this tank empty weighs 23 pounds. Once it's filled with water, it weighs 96.5 pounds, and so that would be about 73.5 pounds of water in there. And that guy, that would be the bottom half that I removed. So I'd say that's about a pound of steel there, and maybe a little bit more. But when that is full with water right to the rim, that would be 13.5 pounds. So minus that pound and a half for the steel, we'd have about 12 pounds of water for that half. But now we got to remember that when we mated the larger tank to the top of the 20-pound tank, it was actually dome shaped. So it would be essentially double this volume of water that we have removed from the larger tank. So if we double that, we got 24 pounds roughly of water that we would have been subtracting from that 73. So now we have, I would say, a fairly accurate number for the volume of the version 1 water vessel. And so based on those numbers, the 73.5 minus the 24, that gives us 49 and change. The easier way to look at this is if we convert that 49 and change to kilograms. That would be about 22.5 kilos. And a liter of water basically weighs 1 kilo. So yeah, if we have 22.5 kilos of water in there, that means we have 22.5 liters. And so for those imperial folk, that works out to 6.9-ish gallons of water. So I've been estimating, yeah, I think around 6.5. So I might have been a little bit gracious on that, but now I think I have a really good understanding for the volume of that first version water heater and what we were trying to heat there. So okay, so we have our tank out. We're out by the shed now, by the mini snowcat. It's just a little bit better place to work here, so I don't get the hot tub and everything all dusty and covered in grinding wheel debris. So what I'm going to do is start by cutting off this top handle, and then once I've got that done, we're going to use the 7-inch grinder sander with some 60 grit to take the paint off, and then that way, once we do light this thing, it's not going to create a bunch of smoke and stuff. Next step here is to get this back inside, and we're going to start to cut this apart. We're going to cut out the top, get our hole for the flue installed, go to the bottom, and yeah, keep moving on from there. All right, we're back in the shop, and although it is bright and sunny outside, that's a little deceiving. It is well below freezing, and there is a wicked north wind. So standing out by the shed, sanding off the paint from this tank was not very pleasant. But I digress on that, and we will continue to get this tank ready for installing that stainless steel coil and whatnot. So as far as the design goes for this tank, it's going to be very similar to the combustion chamber for the first version of water heater. And what I want to do is go as far as to use the same inlet diameter, the same flue diameter, the same burn pot, the same oil delivery. Try and keep all of that as similar as possible, so that we can really compare the performance of this type of a water heater versus this second version type of water heater. And so, like I said, I'm going to go as far as to use the same configuration, the same burner. All of those will be very similar. So we're going to see a lot of the same fabrication steps in this version 2 as in version 1. So yeah, the first step here is to use the template. We're going to screw it in with a couple self-tappers and cut out the top. We're going to do the bottom. And then what we are going to do to be able to get the actual coil inside of that combustion chamber, we are going to split the tank in half. And when we do that, we're going to just leave a couple notches at that split point, and we're going to bend the stainless steel coil so that it actually sits kind of something like this inside of the tank. There, like that. And we will route these tubes so that they come out exactly at that split point there. So if we do need to take the coil out or do any kind of maintenance on it, basically it's going to be a matter of unbolting the two halves of the combustion chamber, and then everything should be accessible. So. All right, so I've got the top and the bottom hole both cut. That worked out well. Actually using my little welding table upside down to kind of just strap that in place to hold it was a lot easier than trying to hold that just kind of randomly between my legs while drilling it. So that's done. The next step here, I'm going to start marking out, first of all, where I'm going to put the door. So I'm going to use the same proportions that I have for that door and transfer it over to this tank. The other thing I've got to do now is I want to come up with a plan to split this basically in half, and then give myself some room here to I guess to get this coil in there with a little bit of wiggle room. So if it's kind of about that height, I'm thinking of almost splitting it pretty close to the middle here, maybe just above the middle. And then when I go to reattach it, what I'm going to do is just use some flat bar to create an inner lip around so that it lines up nicely. And then I'll just use some bolts to hold it all together in the end. But yeah, I'm going to start marking out the door and where I'm going to cut it. So I have it all marked out here. This here is the same size door as on that there. And you can see obviously that because that's a shorter tank, the tank seam is right in the middle of the door there. And the tank seam is going to be right at the top here. So I figure I will just continue that cut all the way around. And when I go to put the coil in there, I can get everything mounted and it'll work out well. So it'll just mean that the backer that I install on the inside of this connection here can actually just continue down and in front of the door, and that will form kind of the backer for the door, at least at the top here. But what I'm going to do is take this outside now to out by the shed again, just so it doesn't get all covered in dust in here, and I will cut the tank in two, and I will cut the door and then come on back in. All right, so we got the tank cut in half, and it went pretty well. So this is the lower part of the combustion chamber, and this is the door cutout here. It fits back in there just fine. So what we will do is use some flat bar to back the seams of that door. That's what it looks like from the inside. So we don't get to see that often. But we also have here, this is the top part of the tank, and so it would obviously sit right side up, kind of like that. And in the top part of the tank is where we are going to put our heat exchanger coil. So I'm going to flip the top part upside down now. And I'm just going to use the bottom part of the combustion chamber just to hold it in place, because I don't have enough hands to do that. And so this is our flue pipe. It's 3-inch, just 3-inch tubing. So you can see it kind of fits there like that. And here is our heat exchanger. So this is kind of how it's all going to fit together. And so this is actually going to end a little bit higher up, probably somewhere around there. And what we're going to do is build a cylinder to try and force the combustion gases around the heat exchanger before it exits the flue. So as it sits right now, all of that hot gas is going to go straight out the flue, and we're going to get no interaction with the coil whatsoever. So we're going to change that. We're going to force it so that all of those combustion gases must pass over these coils before they escape. So we're going to go to my whiteboard and try and draw up exactly how that's going to work. All right, so please excuse the crudeness of my whiteboard here, but we're going to look at a cross-section of the water heater as I plan to do it. So this is our 30-pound propane tank, and that kind of tank seam is somewhere in the middle there. We cut out our door kind of like that. And so this will get backed with some flat bar just to kind of seal that joint off so that we get as little air leakage as possible. And then we're going to bring our flue in. It's actually going to extend down quite far. And so as I was mentioning before, the inlet and outlet of the coil are actually intended to be on the bottom here. So we're going to have all those coils like that, and so those are kind of going across, if you will. And so one of those is going to come out right here at that seam, and the other one is going to come out, or actually it goes into the coil, and also come out at that seam here. And so, like I said, that'll be self-draining, so that we, when we disconnect everything, water is going to come out of the coil here. But now, what I want to do is avoid having the flame from here's our burning pot, and here's our air intake with the little holes in it. I want to avoid having all of our hot combustion gases going straight out of the flue. So what we're going to do is build a little bit of a snake's bend here, so that the combustion gases are forced to travel across all of these tubes before they go out of the flue. So what we're going to do is we're going to make a U-shaped kind of piece of steel. So this will be like a large round cylinder. It'll have a flat bottom in it, and if anything, it'll kind of have some flat pieces that extend out to the side. And what we're going to do is we're going to take the hot gases from combustion and make them actually travel up through all of those coils, and they're going to be forced to come back down through this gap here, and then eventually they can escape up the flue. So it'll be the same on this side. They'll kind of work their way around all of those tubes and then go out. And so we'll get a lot of dwell time for all of that hot gas to actually have as much thermal transfer time as possible before they just escape. So we're going to come up with this little, I would say, cylinder, and we're also going to have to find a way that that cylinder perhaps can, through these little supports here, actually hold this heat exchanger tube in place, and so that when everything kind of comes back down on top of the combustion chamber, nothing's going to be falling down, or everything's going to be kind of secure where it is. All right, so I did some manipulating of the stainless tube, and the bender that I got actually broke, and while it broke, it managed to kink the bend that I was hoping to achieve right here. So unfortunately, I'm going to have to use some other type of fitting. I'm thinking of like a compression fitting that would fit around there, and hopefully I can find a 90-degree double compression fitting, and so I can use that 90-degree to kind of turn out and then turn out and then come out of the tank here and have some other kind of fitting to the rest of the plumbing. And I'll probably do the same thing here. I'll look at cutting this tube right here and then just a compression 90 that'll bring the fitting out kind of to there. And that should be how we get the water in and out of the heat exchanger. So the next thing I'm going to do right now is work on, I want to build, it's kind of like imagine a paint can or something that fits around here. So the first thing I need to do is, I'm going to use probably this piece of sandpaper as a template, and you can see it creates a nice kind of circular dish. And so we'll cut one round piece out, and then we'll cut out a long strip of steel, and then we'll kind of form it into a round shape. It doesn't have to be perfectly round, but basically enough so that it fits over the end and will create that kind of channel for the gases to flow. Okay, so I have cut out a strip. I kind of formed it. I obviously don't have a roll break here to make a really nice job of that, but what I'm going to do, I just kind of roughly formed it on the bench here, and it's pretty close. So what I'm going to do is just tack weld a couple places, and as I work my way around, I'll kind of use a clamp to hold it into shape, and then that should be close enough. It does not need to be perfect, so I think we're well within what we need to be doing here. So I'm going to start welding this up. There we go. It is not anywhere near round, but it's going to do just fine. Basically, it's just got to redirect a bunch of hot combustion gases, and it itself is going to get quite hot. So it's going to fit over top of that other pipe. And when I go to actually get this put together, there is going to be probably, I'm going to say at least a 2, maybe 3-inch gap between the bottom of the pipe and the bottom of this little pot here. This is how it all kind of fits together. It's actually looking pretty darn good. So the next step here is to come up with a plan to basically hold everything together so that once we go to put the two halves back together, that everything kind of stays in place. So what I want to do is come up with some kind of way that I can hold this coil, the heat exchanger coil, roughly about the same height as the bottom of this pot here. And I also want to be able to connect everything to the outside of this here. So what I'm thinking of doing is maybe some kind of just crisscross. All right, so I have this mocked up now. This is kind of how everything's going to work out. So I've got it, the little tin here, held in place with 3 points of contact. That should be enough. I'm going to leave this fourth one out of the way for now. I'm just not sure how I'm going to route the plumbing and whatnot. So I have the coil, the heat exchanger coil, just temporarily zip tied onto these little cross members here. Eventually, I'll probably just use some stainless steel wire to wrap them on there permanently, and that should be enough to hold it in place. Once this is flipped around, it's actually going to be sitting down, so it really doesn't need much to hold it in to where it is. So yeah, and what I came up with for holding this in place is this is a 3/8 bolt, a 3/8 nut, and then this little tubing here that I had laying around, it actually, a 3/8 bolt threads into the end of it quite perfectly. So basically, once you thread this through the nut into the piece of tubing, everything is fixed in place. So what I'm going to do now is just flip this over and give us an idea of how this is all going to look. So I've got the top half of the combustion chamber, it's just sitting on the bottom half for now, but you can see how our little gap there creates a channel for all those combustion gases to come up the side through all the tubing down into that little pot, and then between the bottom of that pot and this flue here, we have a 3-inch gap. So there is room for that gas to go down and then up and then out. So that is how I'm hoping that we can really maximize, like I said, the interaction time between the combustion gases and our heat exchanger tube. The next step for me will be to create a little lip here on the inside of the lower tank so that there is some overlap between the bottom of the combustion chamber and the top half. And we'll just use some bolts to attach it together so that it will be able to take it apart and do any kind of maintenance or modifications as necessary. But I don't have that right now, so I can't really finish that part off. The other parts will be, of course, getting some fittings that will work with this stainless tube, creating some hinges, getting the door attached, and getting the little piece of round tubing that sits in the bottom of the combustion chamber welded in place. I'm actually going to steal the burn pot from the other waste oil burning water heater and put it directly into this one, just so that I can save some time and we can get to the testing a little bit sooner than later. That's about all I have. Oh, and I do have one other little top secret, I guess, piece of this build that I'm not going to reveal yet, and hopefully it will help increase the actual operating temperature inside of the combustion chamber, so we don't end up with all of that cherry red steel on the outside, and we can focus a lot more of that energy to where it needs to go. But anyway, that's enough of me for talking and enough of me building for today, so I'm going to take a break now. And if you are enjoying the build, please be sure to like and subscribe, and we'll see you on the next part of this. Thanks for watching.